I haven't done one of these for a while, and it looks like I get a treat. BB13 is graph quadratic functions in standard form. So I love graphing, and I especially like quadratics. So here we go. BB13, I haven't previewed it. Let's take a look and see how it goes. Hopefully it'll give us a graph. It does. Oh, nice. Okay, so they didn't put it in what we call vertex form. Vertex form is a lot easier to deal with, but this isn't bad. And we've got we have our quadratic in standard form here. That's the ax squared plus bx plus c. Okay, I got it. Yeah, there. Okay, so I'm going to write my equation down here. Y equals x squared plus 2x minus 9. And I like to write it with y equals, but it doesn't matter. F of x is the same thing. And what we want is we want to find where our vertex is. And the vertex is always at x equals negative b over 2a. And the reason that that's the case is because if you think about the quadratic formula, the negative b over 2a plus or minus the square root, the plus or minus is the part that makes the two sides what we say that the two sides map onto each other, or that they're congruent. And we say that this thing is the symmetry. This is literally the line of symmetry for this parabola. And it just so happens that when x is equal to negative b over 2a, then the y value that we get for that will give us the point where the vertex is located. So all we have to do is, hopefully you recognize that this is y equals ax squared plus bx plus c, just like when we use the quadratic formula. And a is 1, and b is 2, and c is really negative 9. Be careful, that really is plus negative 9. So negative b over 2a, be careful, is negative 2 over 2 times 1, which is negative 1. This is where my vertex is going to be located for this guy. And I need to find the value of the function at negative 1 in order to find where the vertex is. So let me do this real quick. I'm just going to scroll this up a little bit here if I can. Oh, it's not letting me. Okay, I guess that's as high as it'll go. So what I'll have to do is give myself a little more space up here. All right, so now we want f of negative 1. This is going to be the value of y when x equals negative 1. And we put the negative 1 into the square. Be careful if you just grab your calculator and put negative 1 squared, it's going to say negative 1 plus 2 times negative 1 minus 9. I'm just going to leave it as minus 9. This is positive 1 plus negative 2 plus negative 9, which happens to be negative 10, isn't it? Because this is positive 1 plus negative 2 plus negative 9, and that is negative 10. So negative 1, negative 10 is our vertex, and I put it on the graph if you didn't see it over there. Now I'm going to have to get another point, and the other points are really easy to find. I like to think of this as a kind of like a slope. It's actually what my stretch or compression factor is. And the way to think of it is that this is a standard parabola. In other words, 1 squared is 1, 2 squared is 4, 3 squared is 9. So what I can do is from the vertex, I can go 1 to the right and 1 up. I could also have gone 2 to the right and 1, 2, 3, 4 up. I could have also gone 3 to the right, 1, 2, 3, and up 9, and you'll see that they match what I call a standard parabola. That's it. You find the vertex. You find x equals negative b over 2a. That's your x value. It just so happens that x equals negative 1 is my line of symmetry for this thing, and your vertex is always on the line of symmetry. So this is my line of symmetry right there. God, what a mess. Sorry. That was a bad idea. Okay, so I'll just put it back. I was going to draw my line of symmetry, but it's not working out. So That is the right one, and that's the right one. There we go. So there it is. Let's do another one. I'll go much, much faster on this one, I promise. We're just going to look for the negative b over 2a. So we've got x equals negative 2 over 2 times 1, which again is negative 1. Seems to be a little pattern going on here. And we're going to substitute the negative 1 in, and we get y equals negative 1 squared. Remember, that's inside parentheses, plus 2 times negative 1 plus 7. Well, that is 5 plus 1 more makes 6. So negative 1, 6 is our vertex. Now it's going to be in the positive direction, isn't it? And it's going to be a standard parabola. Standard again, 1 to the right means 1 up, and 2 to the right means 4 up, and so on. Okay, here we go again. We want x equals negative b over 2a. That's negative 2 over 2 times 1. They keep giving me negative 1. Some people are going to think that that's always the case, and it certainly isn't. So my f of negative 1, I'm writing this in different ways just to get you in the habit. That's negative 1 squared plus 2 times negative 1 plus 6. There's my 4, and 1 more makes 5. So f of negative 1 is 5. My vertex is at negative 1, 5. Again, because it has a 1 in front of the x squared, there's a 1 there. That leading coefficient tells you that it's a standard parabola. 1, 1, 2, 4, 3, 9, and so on. I'll do a stretch one if they ever give me one. There we go. Now we'll get to stretch it. So let's do x equals negative b over 2a. Now you need to be very careful. Here's a really common mistake. You see that negative b, and you see that b is negative 6. Very common error is to put a negative 6 here. It's not. It is the opposite of negative 6, all over 2a, 2 times a, and a happens to be 3. And man, they were priming me to get a negative 1 out of that, but this is actually a positive 1, isn't it? Now I still need to substitute my 1 in and find my y value, or my f of 1 in this case, not negative 1. That's going to be 3 times 1 squared minus 6 times 1 plus 6. Well, that's 0, and that's 3. So y equals 3. So 1, 3 is my vertex. Now 1, 3. Now a lot of people are going to go, well, I'm going to go 1, 1. I don't want you to think of this as a slope, but this is what's really happening. My normal parabola would look like this. If this was a standard parabola, it would look like that. That's if my value in front of the x squared was a 1, but it's actually a 3. And what's happening is every point is getting multiplied by 3. That means that this point, instead of being 1, 1, is at 1, 1, 2, 3. It's right there. Now, a lot of people are going to say, oh, then I can just treat this like it's a slope and count the slope. That doesn't work, especially when you're talking about fractions. Any kind of fraction will not work that way. And I'll do one. Hopefully they'll give us a fraction maybe with a half or something. And I'll show you that you cannot go up 1 and over 2. It doesn't work. I know you're thinking that the 3 over 1 works in this case, so who cares? But it matters. What I've done is I've pulled the parabola up 3 times as high. So if I went over to 2, it's going to be, instead of being at 2, 4, it's going to be at 2, 12. Now that's a very different thing than a 3 slope. So there it is. Let's submit it and do another one. Okay, so x is equal to negative b over 2a. Oh, this one has a leading coefficient with a negative. That means that my parabola is going to go down and be very steep. So it's going to look like this, isn't it? So I know that already because of the negative 4. We're going to go ahead and substitute our x equals negative b over 2a. Negative 16 over 2 times a is negative 4. And that's going to be negative 16 over negative 8, which is 2. My vertex is on the line x equals 2, which is also my line of symmetry. That's right. So we're going to substitute 2 into our function, or find the y value when x equals 2, same idea. And we've got 2 squared plus 16 times 2 minus 12. And I'm going to go ahead and simplify this a little bit so that we can play with it a little easier. This is going to be negative 16. Be careful, some people are going to want to multiply and then square. That's not right. Plus 32 minus 12. And this is 16, isn't it? Minus 12 is 4. So my vertex is going to be at 2, 4. 2, 4. There's my vertex. Now, if this was a negative 1 instead of a negative 4 as my leading coefficient, a negative 1 would look like this. Just like that. And 2 would go down 4, wouldn't it? And 3 would go down 9, and so on. But the difference is this one has been multiplied by 4. So instead of going to 1, negative 1, it's going to go to 1, 1, 2, 3, 4, which is right there. And you can see that it is steeper, and it does look a bit like I told you. And it is at 2, 4, which is our vertex. There we go. All right, x equals negative b over 2a. X equals negative 4, and I'll put the 4 inside parentheses, over 2 times a, which is negative 1. Now this gives us a positive 2 for our x value. I need to substitute the 2 in. And I get negative 2. Notice the negatives outside the parentheses this time. Plus 4 times 2 plus 4. Well, this is 12, and that's minus 4, so this is going to be 8. So f of 2 is 8, and our vertex is at the point 2, 8. 2, 8 is our vertex. Oops. Come on. There it is. Sorry, I was off by a half there, and it would have messed me up. So 2, 8 is my vertex. Now, a negative 1 means that it's a standard parabola going down. So 1 squared times negative 1 is negative 1. 2 squared is negative 4. When you multiply by negative 1 is negative 4, and so on. There it is. Let's do another one. Come on. Oh, man. I'm getting lag. Oh, there we go. Good, good, good. Okay. All right. Negative b over 2a. I'm going to go a little faster. Oops. Come on. There we go. Negative b over 2 times a is negative 4. This one's different. So we're going to substitute the negative 4 in. We're going to find f of negative 4, which is the y value when x is negative 4. That's going to be positive 16 plus negative 32 plus 8. So that's going to be negative 8, isn't it? So negative 4, negative 8 is our vertex. Negative 4, oh, we got to move it up a little bit. There we go. Negative 4, negative 8 is our vertex. And we have a 1 as our leading coefficient. There is a 1 in front of that x squared. It was x squared plus 8x plus 8. Negative x squared, sorry. Oh, wait a minute. Was it negative x squared? Wait, no, it was just x squared. Hang on. Okay. So, yeah, negative 4, negative 8 is our vertex, and it is a standard parabola, isn't it? That means it's going to look like that. Now, it's kind of interesting that my x values, these are called the roots or the zeros. They don't work out evenly because this is non-factorable. This looks like x plus 4 squared, but it would have to have a 16 at the end to be x plus 4 squared. Anyway, there it is. It's a standard parabola. Come on. Oh, man, I'm getting a lot of lag. Let me close this just in case so that I'm not recording that. I don't know why it's giving me announcements. All right. A very similar type of problem. We've got x equals negative b. Be careful, there's that double negative there. 2 times 1, which happens to be 8 over 2, which is 4. This time we're going to substitute a 4 in. So we've got f of 4 equals 4 squared minus 8 times 4 plus 8. That's going to be 16 minus 32 plus 8, which again ends up being, wow, interesting. That's negative 8, isn't it? So we've got 4 negative 8 on the other side this time. 4 negative 8, and we have a standard parabola. I'm going to go a little faster this time. All right. This one is, let's put in x equals negative b over 2a, 4. Sorry, it's kind of ugly there. And that is going to be negative 2. I'm going to substitute in my f of negative 2, which is 4 times negative 2 squared plus 16 times negative 2 plus 20. That's going to be positive 16 plus negative 32 plus 20. And that's going to be positive 4, isn't it? So negative 2, 4 is our vertex. And we have a multiplier of 4 as our leading coefficient. So that means that 1 squared is 1, but when we multiply it by the 4, we go up 1, 2, 3, 4, and there it is. Okay, we've got negative b over 2a. That's going to be negative 10 over 2 times negative 5, which is 1. We're substitute in the 1. I'm going to go a little faster. Y is equal to negative 5 plus 10 minus 4. I just substituted the 1 in for all those x's. And that's going to give us 1. So my vertex is at 1, 1. Now I'm going to count 1, 1 would be a normal parabola. So a normal parabola would look like that, but it's being multiplied by negative 5. So every normal point is going to go be multiplied by negative 5, which means this point is going to go 1, 2, 3, 4, 5, which is right. Oh, I moved the vertex, darn it. Sorry. Let me get rid of that. There we go. 1, 1, and then right there. Oh, I'm off a little. Let me get it down in here where it belongs. There it is. So 1 down negative 5, and I know you're thinking the slope works, but it doesn't. Anyway, there it is. They're still not giving me any fractions. Oh, well. So we've got x equals negative 16 over 2a, which again is 1, and I'm going to substitute in my 1 to get my y value, and I'm going to get negative 8 plus 16 minus 10, which is negative 2. And so 1, negative 2 is my vertex, 1, negative 2, and I have a negative 8 as my leading coefficient. And it's going to be way down there, isn't it? And there we go. Hopefully they'll give us a fractional leading coefficient pretty soon. Nope. We've got x equals negative b. Be careful, there's a double negative over 2a. And that's going to be 4 over 2, which is 2. And I'm going to substitute the 2 in. That's going to give me 4 minus 8 minus 3, which is negative 7. So 2, negative 7 is my vertex, and it's a standard parabola. 2, negative 7 is right there, and it's standard. So there we go. There it is. I knew they'd give me one eventually. Okay. For those of you who were absolutely convinced I was a little crazy and that you can't count the slope, you cannot count the slope. Here's what we do. And you're going to like the way, I think you'll like the way I do these. So here's what I'm going to do. I'm going to substitute in my negative b over 2a. Some people are going to be absolutely adamant about using a calculator, which is a really bad idea. You really need to learn how to manipulate fractions a little bit. But anyway, x equals negative b, which is negative 4/3, double negative there, over 2a, which is 2 times negative 1/3. Okay, so that's 4/3 divided by negative 2/3. Now I know this looks really ugly and long and it's an ugly process, but it isn't that bad. Remember how fractions work. You take 4/3, you change it to multiplying by the reciprocal, and look what we get. -2 for our x. Now I need to substitute the -2 in and get my value for my function at -2. So I've got f of -2 is equal to -1/3 times -2 squared minus 4/3 times -2 plus 5/3. Now I'm going to do just a couple of things here. I am going to square this and put the -1/3 with it, which is -4/3. I'm going to make this plus a negative, which gives me positive 8/3. And then I'm going to add 5/3 to that. Well, this isn't that bad. That's going to be 4/3 plus 5/3, which is 9/3. That happens to be 3. So -2, 3 is our vertex. There's my vertex. Okay, so here's the part where I like to really, I'm gonna have to mess with my graph a little bit. So if this was a -1, instead of a -1/3, it would look like this, wouldn't it? That would be it. Simple. Now, the problem is that the leading coefficient is not -1. My a value is -1/3. So what's happening is that whatever value I get from looking at the difference from my 0, I think of this as kind of like a new origin. So in my head, I'm thinking of this point right here. Let me just get rid of it for a second here. I'm thinking of this point as a new vertex, or a new origin, sorry. And that, just think of that as a new origin. Now, what would happen if I went 3 to the right from the origin? 3 squared is 9, isn't it? But I'm multiplying that by -1/3, which means I have to go down 3. 1, 2, 3. Did you get that? It'll make more sense to you if you think of it like this. I would like to make a drawing just for you, just really quick. So normally this thing would look like this. And normally this I treat as if it's a brand new origin. That's how I think of it. Then my 3, 1, 2, 3 would be, actually it would be right there, wouldn't it? 3 would be here at -1. But here's what would happen. If it was a -1, then 3 squared would give me -9. But it's not a -1, it's -1/3. So I multiplied my 9 by -1/3, and I got -3, which is why it goes through that point right there. Hopefully it makes sense to you. It's what I basically did is I took a standard parabola, which would be this guy, and I pushed it back to 1/3 as far. I think of it as a compression. So there you have it. Hopefully it makes sense. Let's see if they give me one more fraction and I'll do it for you. Yeah, there we go. 1/4 is going to be a really good one. And in fact, let me find my values real quick. So we've got x equals -b over 2a. This isn't that bad. So basically I'm taking 4 and dividing it by a half. How many halves go into 4? I'll bet you can do it in your head. It's 8, isn't it? Think about it. How many half dollars do you have if you have $4? Well, you have 8 of them. If I divide 4 into halves, I get 8 halves. That's I like to think about fractional division in a different way, maybe. So anyway, x is 8. So let's put in our 8. So f of 8 is 1/4 times 8 squared minus 4 times 8 plus 11. This is going to be 64 times 1/4, which is 16. Well, that is 27 when you add the positives, and minus 32 gives us -7. So we're at, 8, -7. There's our vertex. All right. Now what I'm going to do, I'm going to get rid of this for just a second so I can show you. I'm going to draw something for you. And I think this one will be easier to understand, in fact, because it's a positive fraction. So what I've got is I've got 8, -7, and I'm just going to estimate it. Let's pretend like it's here. This is going to be my 8, -7, okay? That's my vertex. Now, if this was a 1 instead of a 1/4, what would happen? Well, if this is my new origin, then 1 squared is 1, 2 squared is 1, 2, 3, 4, and 3 squared is 9, and 4 squared is 16. So from this point, and of course it's symmetric, isn't it? Now this is not a standard parabola because it's got a 1/4 in front of it. So what happens is these points right here get compressed to 1/4 as high as they normally would, which means that instead of going to 4/16, it actually goes to 4/4. So we're going to pull this down to 1/4 as high, and it's going to be where the 2 would normally be, the 4 is now. And so there's my new parabola. Now, if it was a standard one, then it would look like this. If it was a 1 in front of it, then it would be the standard. Now, a lot of people are going to go, well, why don't you just count the slope up 1 and over 4? Because it doesn't work. If I go 1 to the right, I have to go 1/4 up, and you can't visualize that very easily. So anyway, there it is. Hopefully it makes sense to you. I'm going to go to 8, -7, which is right there. And then 4 over is going to be 4 up. So 1, 2, 3, 4, 1, 2, 3, 4. Because instead of going to 16, it goes to 4. 1/4 of 16 is 4. So hopefully it makes sense. And I think that's enough time. I've spent almost 30 minutes on it. I might do one more. We'll see what it looks like. I'll submit this one real quick here. What? Oh, geez. Where did I make a mistake? Come on. Did I not count correctly? Oh, I put it at -5. No. Oh, I must have made an error. I didn't add right. Sorry, guys. Everything was correct except that my vertex was, I put it -7 instead of -5. Sorry about that. All right. Maybe we'll do one more. Nah, it's not very interesting. Well, darn. Hate it when I make mistakes, but there you have it. Watch out for your vertex values. And in this particular case, what are we going to have? Let's see if I can do it real quick. -b/2a is going to be +5, isn't it? And then we substitute the +5 in, and we get 9. I think it's 9. And then it's going to be a standard parabola going down. So let's see if I can keep from messing this up. 5, 9, it's a standard parabola going down. I believe that's right, but I'm going to double check it just to make sure. X is equal to -b/2a, and that is +5. And when we substitute the 5 in, we get -25 plus 50 minus 16, and 25 minus 16 is 9. Yep, looks right. Anyway, a little practice goes a long way. I was going to see if I got another fraction, but I didn't. So I'll see you next time. Bye, guys.